At first glance, a rotary engine doesn't even look like it should work. There are no pistons, no cylinders, just a spinning triangle inside a peanut-shaped housing. And yet, somehow, it produces power. It revs sky high, and it has a sound all its own. Rotary engines don't just take a different path. They ditch the map entirely. They've been used in sports cars, aircraft, motorcycles, and even race-winning prototypes. They're far less common than piston engines, but they've built a reputation for being lightweight, high-revving, and oddly elegant. Today, we're breaking down exactly how a rotary engine works, from the way the rotor moves, to what makes the design so unique, and why some people will never stop loving them. Second, what is a rotary engine? A rotary engine, also called a Wankel engine, is a type of internal combustion engine, but instead of using pistons that move up and down, it uses a single rotor that spins in a circular motion to generate power. The rotor is shaped like a triangle with rounded sides. It moves inside a housing that looks like a stretched out oval. As the rotor turns, the volume between its sides and the housing changes. This allows it to pull in air and fuel, compress it, ignite it, and push out exhaust, all while spinning continuously. This design has major advantages. It's smaller, it has fewer moving parts, and it delivers smooth power at high RPMs. That's why rotary engines became popular in lightweight performance cars, like the Mazda RX series. But to truly understand how it works, we need to look inside. Third core components. Let's meet the key parts of a rotary engine. Rotor. The rotor is the triangular heart of the engine. It replaces the pistons. Each of its three curved faces handles a different part of the combustion process. And it doesn't just spin. It orbits inside the housing in a complex rolling motion. Eccentric shaft. Think of this like a crankshaft in a piston engine, but it's designed for the rotor's off-center, orbiting motion. As the rotor moves, it turns this shaft, which sends power to the wheels. Housing. This is the chamber the rotor moves through. It's shaped like a stretched oval, technically an epitrochoid. As the rotor spins, it forms sealed chambers with the housing walls. These chambers expand and shrink to move air and fuel through the engine. Apex seals. At each corner of the rotor, you'll find apex seals. These thin strips press against the housing to keep each chamber sealed. They're essential for compression, but also the most failure-prone part of the engine. Ports. Rotary engines don't use valves. Instead, they have intake and exhaust ports, simple openings in the housing. The rotor's position determines when air and exhaust flow in or out. Everything in a rotary engine is built for simplicity. No camshafts, no timing chains, just a rotor spinning inside a shell. 4. How the rotary cycle works. There are 4 stages, just like a piston engine: intake, compression, power, and exhaust. But here, the rotor handles all of them at the same time with each of its 3 faces. First, intake. As the rotor turns, one chamber expands. This draws in air and fuel through the intake port. Second, compression. That same chamber starts to shrink. The air-fuel mixture is squeezed tighter. Third, power. At the right moment, the spark plug fires. The mixture explodes, pushing the rotor along its path. This creates the power that spins the shaft. 4. Exhaust. The chamber rotates further, opening to the exhaust port. The burned gases exit, and the process repeats, continuously. That's why rotary engines feel so smooth. There's always power being made, somewhere in the cycle. V. How motion is created. So how does this triangle make the wheels move? As the rotor spins, its faces stay pressed against the housing, thanks to those apex seals. This motion drives the eccentric shaft. There's no need to convert up and down motion into rotation. It's already rotating. That's why rotary engines rev so easily. Everything is already spinning in the direction you want. Sixth, strengths of rotary engines. Rotary engines bring some real advantages. Compact and lightweight. They're small. They're light. No pistons, no valves, no bulky timing systems. Perfect for lightweight cars. High revving nature. Their motion is smooth and balanced. That means they can spin fast and keep going. Power to weight ratio. For their size, they produce a lot of power. That makes them ideal for sports cars, motorcycles, even aircraft. Mechanical simplicity. Fewer parts, cleaner design. Once you understand the rotor's path, it all just makes sense. Seventh common issues, but rotary engines aren't perfect. Apex seal wear. The biggest issue is apex seal wear. These seals are in constant contact with the housing. Over time, they wear down, leading to loss of compression and power. Fuel efficiency. They burn more fuel, especially at lower RPMs. The combustion chamber shape isn't ideal for clean burns. Oil consumption. Rotary engines inject oil directly into the chamber. This keeps seals lubricated, but means you burn oil by design. You'll need to top off more often. Emissions. Burning both fuel and oil makes clean emissions tough. That's part of why they fell out of favor. Maintenance? They're mechanically simple, but still need attention. Compression checks, oil level monitoring, regular upkeep. It's not a set it and forget it engine. Vate, rotary in cars. Despite those downsides, rotary engines made their mark, thanks to Mazda. Mazda RX-7. The RX-7 is a legend. Lightweight, rear-wheel drive, known for sharp handling and a rev-happy engine. The rotary engine gave it character. Smooth, eager, and fun to drive. Mazda RX-8. Next came the RX-8. It had 4 doors, a new chassis, and the same rotary sole. Not as iconic, but still important for rotary development. Racing success. In 1991, Mazda won the 24 Hours of Le Mans. Their car, the 787B, was rotary-powered. It screamed past 9,000 RPM for 24 hours straight. It's still the only rotary-powered car to ever win the race. Mazda didn't just use rotary engines. They believed in them. 9. Why enthusiasts still love it. Even with quirks, rotary fans are diehard. Rotary cars drive differently. They rev high, they respond fast, and the engine's low weight makes the whole car feel nimble. The design is elegant. No valves, no cams, just a rotor spinning in a sealed housing. They're also powerful when tuned right. You can build serious speed from a tiny block. But more than anything, it's the community. Owners, tuners, racers. There's a culture around rotary engines. It's not just a machine, it's a movement. Wrap up. The rotary engine isn't like anything else, and that's the point. It ditches pistons and valves for a spinning triangle. It's compact, lightweight, high revving, and it delivers power in a way no piston engine can. Sure, there are trade-offs: apex seal wear, fuel economy, oil use. But for the people who get it, rotary engines are more than machines. They're a different way of thinking. They may never go fully mainstream again, but they've already carved out a permanent spot in automotive history.